In this module, we're going to work with responsive design testing branch. Check out this one. We're going to upgrade our solution with vocal execution attribute to support mobile emulation. We're going to create a layout assertion library. We're going to implement that into our framework to support it, so that we can determine if a website functions as intended when viewing using various browsers, devices, and operating systems. This will be especially important again when you run the test against different, for example, mobile web browsers. You can pick between many different browser and browser versions. Hi guys, greetings from Bulgaria. I'm Anton, and in this module we're going to cover responsive design testing. This is a module part of our Advanced Test Automation Frameworks Development course. But before we begin, hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Also, check the awesome Lambda Test blog, where you can find many detailed articles about automated testing. They can help you to be a much better test automation engineer. In the links below, you will find links to reference materials like articles and websites, and also a link to the GitHub repo of the framework. This is the GitHub repo, Polaris-wide test framework, and I suggest to watch the modules sequentially, one by one. And for each particular module, we have a different branch from this GitHub repo. So right now, in this module, we're going to work with the responsive design testing branch. So check out this one. I suggest to clone the repo, check out the branch, and work besides me while I explain the code, because it's quite a lot. It will be easier for you to follow. Now let's back. Also, below you will find some time links where you can jump into particular sections of the video if you want just to skip a particular part. I won't repeat the whole course overview, but again, I suggest to check all the modules sequentially. But first we defined the scope and the requirements for our framework. Then we built the web and the mobile core modules out of our framework. We extended it with plugin architecture, and right now we're configuring and executing our tests using attributes for controlling the native mobile applications and the browsers. And in this particular module, we're going to cover responsive design testing. So first, we're going to discuss shortly what this is. In the links below, you will find a link to a YouTube video where I explained it in much more details when we were covering Selenium, the new Selenium CDP integration by directional APIs. After that, we're going to upgrade our solution with vocal execution attribute to support mobile emulation. I'm going to use the Chromium engine for that. And later we are going to upgrade it to support as well execution in the Lambda Test Cloud for the web applications. We're going to create a layout assertion library. In a minute, I'm going to explain what is this. And this layout assertion library, it will also support this native and hybrid mobile applications that instead of running them on emulators, we're going to refactor our code to support executing these applications on real devices in the Lambda Test Cloud. Many things to cover, so let's get started. First, let's cover in short, discuss the responsive design testing. In order to do so, I'm going to open our favorite e-commerce playground website. Also, in the links below, you will find links to these two articles from the Lambda Test blog: responsive testing with examples and best practices, and responsive web design testing checklist, all you need to know. Of course, I summarized everything really shortly to explain it. But responsive responsive web design automatically adjusts the website onto different screen sizes, resolutions, and orientation, like this one here. So if I'm on a 7.1 inch device, the elements should be scaled up automatically from what they would be on 5.5 inch device. Today, this practice has become more critical than ever as more and more people are viewing your website on different screens and devices. Again, here some of the features, as you can see, the order, the layout of the elements is different. We have 3 of them, and when we are on a smaller screen, everything reordered, the layout is reordered. So there are several types of responsiveness testing that can be performed to ensure that the website is responsive and functions correctly on a variety of devices and screen sizes. The first one is visual regression testing, which is part of the regression testing that involves taking screenshots of a website on different devices and comparing them to ensure that the layout and the design are consistent across different screens. Of course, we cannot incorporate that into the framework, but basically the Lambda test cloud supports that. As you can see, I entered here the URL, the same URL that I showed you before, and I picked many different devices, mobile devices here, and the Lambda test cloud made these screenshots here that I can check later for this visual regression testing. Then we have the cross-browser testing, cross-browser compatibility testing. This is the most significant kind of front-end testing. We're going to implement that into our framework to support it so that we can determine if a website functions as intended when viewing using various browsers, devices, and operating systems. Actually, my tests were caught some bugs. For example, this autocomplete here, it wasn't working on some of the devices, which is excellent because Lambda test put them on purpose, of course, on this website. Then we have, of course, the functional testing that we are going to do, that it's part of this cross-browser testing. We have performance testing, usability. We're going to talk about them in later modules. Now, let's focus on how we can implement, initially without the cloud, this type of mobile emulation into our framework. I already implemented that and I'm going to show you. I extended our local execution attribute here to support mobile emulation similar to Chrome. Now, as you can see, we have additional properties here, mobile emulation, device name, the different sizes, like that. I can change and pick from different sizes. I can pick for different user agents. In a minute, I'm going to explain what is the user agent. How I decided to put all of those here? Well, you can open developerschrome.com. I'm going to put that into the reference links. This is the developer documentation for Chrome, and they have a very, very good explanation about mobile emulation. They have some code here because, you know, Chrome driver is their main driver and suggest way for automating. This is why they have a native capability for simulating that. This means that we're going to use the Chromium driver that it's supported by Chrome and Edge to do this type of emulation. As you can see, they allow us here to change the width, the height, the pixel ratio. The pixel ratio is very important. This is the density of the pixels for different mobile devices. We can change the user agent that I'm going to explain in a minute, and we can basically pick different devices here. This is the device name. So the way this works is I extended our browser configuration. If you remember, we had some constructors for controlling which is the browser, what is the life cycle, restart if started, reuse the browser, etc. Also, we had the execution type, whether this is a grid, Lambda test, or locally. For now, we'll keep it locally, but then we're going to implement the missing functionality. And now I added these new 5 properties: the size, pixel ratio that you saw, the device name, the user agent, and whether the mobile emulation is on and off. The size is just a regular struct that comes from .NET, which contains properties for width and height. Alright, after that we have a bunch of helper classes and enumerations. As you saw here, we have this enum called mobile, this class with, this is basically a class here, part of the browser execution namespace that contains all of the devices names that Chromium can emulate. Of course, there are much more, but for simplicity, I just pick a few of them. Most of the time, we're going to use this Galaxy S20 Ultra. Then we have 3 enumerations that are containing the most popular resolutions and sizes of phones. I just picked them from Google Analytics. We have a similar one for tablets and for desktop window sizes. Of course, you can extend that, you can bring your own custom sizes, it's up to you. Also, we have one more class here, window size resolver here. This is a utility class that works with these enumerations, and usually if we check lambda test and in other places, they don't accept the size, but instead they're working with something like these strings, where we, basically this means this is a typical resolution string, right? And in some cases, in some instances, we will have to use this type of strings. In other cases, like the native WebDriver, it works with this struct, which is size. This is why I have a few methods. The first one accepts this particular string with X and separates them and initializes the size. Also, we have 3 methods, 3 static methods that accepts our enumerations using a switch statement to initialize the proper size struct here. We have the same for accepting the mobile window size and the same for the tablet. And also we have one extension method to the size struct that it's converting the size back to this string resolution. That's it. After that, I extended further. I added a few constructors to our local execution attribute here. We have new constructors. Don't worry, in the next video when we talk about global settings, whether this is with options classes or with setting files, we're going to remove all of those constructors, and instead we'll have separate options classes, settings classes, and and we're going to use the options design pattern. But yeah, we have these constructors here that accepts now, as you can see, the 3 enumerations, and also if it's a mobile or tablet, we have the pixel ratio and the user agent. And yeah, basically we are initializing this browser configuration. The next big part, we're not changing at all here the browser lifecycle plugin. However, we need some changes to our driver factory. In our driver factory, we have now a new line, this line here, that basically has a new method called initialize mobile emulation options. As you can see, we are accepting the browser configuration. And if we go inside, this is a private static method here. It's returning Chromium mobile emulation device settings. This is a special class that if we hover, you will see that it comes from the Selenium NuGet package. And what we do, if the mobile emulation is on or it's true, then we are initializing this to, we are creating a new instance of this Chromium mobile emulation device settings, and we are initializing the user agent, the width, the height, the enabled touch, and the pixel ratio. I forgot to mention about the mobile user agents. This is another class with these long strings here. What is the user agent? The user agent is a string, is a text string that a web browser or other client sends to a web server in the HTTP headers of a request. This string identifies the client software making the request and provides information about the client, such as the browser type, the operating system, and the device. As you can see, we have the device, we have also the operating system here, etc. And the web server can use the user agent string to tailor the responses based on the capabilities of the client. Many often, especially in the front-end JavaScript files, especially for older browsers like Internet Explorer, it's very typical to base your CSS logic, for example, JavaScript based on these user agents and reorder the elements differently or style them differently, etc. Because some browsers are not supporting everything, for example, for new CSS, etc. And the practical usage of this is that we can emulate different devices like mobile against desktop to test responsive designs. We can simulate different browser versions to ensure compatibility. We can check how different user agents affect the behavior and rendering of your web application. And yeah, by setting a custom user agent string, you can effectively test and debug your web application under various conditions, ensuring a consistent user experience across different devices and browsers. All right. Next, let's return to the driver factory here. So we are initializing all the user agent, the width, the height, enabling touch events in the pixel ratio. That's fine. And then if we return to our start method here, you will notice that this mobile emulation, this if here, whether mobile emulation is enabled or not, we are initializing Edge and Chrome options, both, because this is supported only for Chromium. You can later, under the Firefox cases here and Safari, you can throw unsupported exception. And the Chrome options here, they have this special method enable mobile emulation that accepts the mobile emulation options that we initialized and the device name. That's it. And after that, everything works like we're executing on a particular mobile device. Let me show you right now. Again, we extended the whole execution. This means that I put it here a breakpoint point, debug point, and I'm going to debug my test. Mobile emulation here is on. And let's hit in action. The rebuild happened and we are waiting just a few seconds. Now you'll see that the browser is open full screen now. However, as you can see here, we are in mobile emulation, and the site was emulated on this particular mobile device. Everything was reordered, the layout is different, and we can later now do the layout testing. In order to implement the layout testing library, what we are going to do? Again, the layout testing, we can do it together with style testing. This is very important because many often styles will be different, but they're really important for when you check them on different mobile devices. Whether, for example, you have the same font, the font size, etc. In our library, we want to check that this particular input is on top of this dropdown, that this button is below this dropdown, that, for example, this list is right of this grid, or that these two buttons are aligned horizontally, or that these two are aligned vertically. So how we can do that? Again, we want this library to be available not only for checking websites, but also it's absolutely valid if we execute our native application on a mobile device. It will be important for you to again do this type of layout testing, especially when you use the app service for rotating the phone, and all the elements will be reordered, and this should work properly. Or some application is forbidden, to be changed, their layout to be changed. So the way this works is, let me stop the debugging, is that I already created such a test. Let's see how our library works, and then I'm going to explain how I implemented it. But yeah, I have page objects here. And one more trick, by the way, you will notice that here I have a mobile homepage, and here I have a regular homepage. What is the difference and why I have two versions of my homepage? Well, many often, since the page is reordered, some elements are visible only on mobile, some elements are visible only for the regular page. This is exactly what is happening in our case. For example, here, the locator for this button is different than the locator here. The same is valid for this input. This, as you can see, we have three elements. The first element located, as you can see, the first right now is not actually the first one here is our search. However, the same locator is not working. As you can see, the first one is not here, but it's the second one. So again, and if you check the button, it's totally different locator that you cannot find it with this XPath. So some frameworks, like for example Tata or doing your research, if you watch the first module, they support different syntax for searching for that. For example, here some of the frameworks are using attributes for mentioning which are the locators, or they have different methods for chaining different locators if one is not working but the other. I don't want to overcomplicate the framework. This is why I left it like this. I prefer to have base pages where maybe these properties can be abstract and you can just re-implement them for the mobile and for regular version. Right now I just copy paste them and switch the locators, but usually the approach is that you have one base page that will be the base for the mobile, and then for the desktop version of your page. That's it. And all of the methods probably will stay the same. However, again, on the mobile view, most of the cases you don't have autocomplete, so even the actions are a little bit different. The behavior is different. Again, there might be some bugs right now. If you run the test on mobile emulation, you will see that some of the functions of our website are not working, and this totally makes sense. This is why we are doing this responsive design testing. Now let's return to our tests. If you remember, the layout library, it needs to check whether a particular element is on top of another element, or below it, or right of, or left of, or we can check the height or the width, or we can even check the whether the elements are aligned horizontally or vertically. I implemented just part of it. I have two versions. I'm going to explain only the first, and I'm going to show you how the second works. The first version that you see here, it contains some extension methods to my elements, and each element out of my library, when I add this using here for the layout, Polaris core layout, this will add these assertions and they will become available to me. We can say this particular element is above of this select, or I have a few overloads for example, saying above of, greater than, and then I can provide pixels here, exact pixels, or assert below of something, then provide other pixels. We have many overloads like greater than, greater or equal than, less than equal, approximately, etc. There are a lot of overloads, as you will see in a minute. Also we have similar assert methods for checking whether an element is right of something or left of something, and we have Also methods for checking the height of the element and the width of the element. Again, with checking with pixels. And this will be especially important again when you run the test against different, for example, mobile web browsers or screen resolutions. Even it will be one thing on one laptop, it will be totally different on a 24 inches monitor, right? And then the second version is using a fluent syntax. It's using a fluent builder. If you check one of the videos about Selenium on the 𝐷𝒐𝒏 YouTube channel, I already explained that in Java. Here you can check the code yourself. Again, it's a little bit more complex and we won't have the time. If you prefer this fluent syntax, every time we will have to call validate. However, the code is significantly less because this was implemented only in, I think, 5 files, 6 files, and here we have many of them, as you'll see in a minute. And here we have much less number of methods because we don't have all of those overloads, but instead we have like chaining methods. For example, you have equal, you have greater than or equal. Basically, by calling these additional methods, you can supply the different pixels. And yeah, as you can see here, we are running the mobile emulation on Galaxy S20 on this particular screen size, etc. Let's see how this works. Let's execute this test. And since I want this library to be available for my mobile test as well, as you can see, the test failed for some reason. Element was not interactable. Anyway, sometimes this happens. Actually, this is the one that I want to show you. It's different again, and here we have also this assertion library. In a minute we're going to see how this works, but again, I'm going to explain how this works. We're going to check the CSS properties for all of them. For the border color, for font family, actually here we call the book because, as I told you, there is a book in the responsiveness. But yeah, here we implemented that for the home page for this particular resolution, and I asserted the border color, the font family, the font size, the font weight, and the text align. In a minute, I'm going to show you how this works. I implemented absolutely the same, but for our mobile framework here. And let me show you. In a minute, in the second part, I'm going to show you how this lambda test attribute is working, but this will allow us to execute our native apps into the lambda test cloud, which is quite awesome. But also, as you can see, I can execute them again in lambda test, but I can start a separate activity or open a particular view. And after that, I have very similar no method that I'm working right now with totally different components. They're actually mobile. As you will see, we are going to reuse this layout library for both syntaxes, for mobile and for web as well. We have similar methods: assert above, greater than, less than. Also, we have this additional aside. As you can see, we can provide any number of elements here to check whether they are aligned horizontally or vertically, or centered or right, etc. And we can assert the height and the width. How this is possible, this to be like available for both? Well, I created this namespace here called layout. It's inside our Polaris core framework. We have version 1 and version 2. Again, you can compare the size, and I haven't even implemented all of the methods for this version here. Again, this version is simpler. This is a little bit more advanced because we are using fluent builder pattern. It contains a lot of delegates, functions, This is why it's a little bit more complex. If you're interested in that, you can again read about this fluent builder pattern. We implemented something similar when we were talking about builder design pattern on the 𝐷𝒐𝒏 YouTube channel. I will put the link below. Now, for our first version, it's really simple. Again, as you can see, it's in the core project. We're not copying it in web and mobile. It's actually containing static classes, and actually all of those files here, they're the same class because this is a partial class. All of them are the same class, but they're partial. Again, I'm doing that because it's easier for me if I want to add something to a particular file or fix something. It's easier for me to orient myself instead of putting everything inside a single file. You will notice that they're extending this iLayout component interface. We are not working with web components or Android components or with any of the native elements. And this is actually how we are achieving this reusability among the two core modules of our framework. If we open this iLayout component interface, you will notice that the only thing that this iLayout component has is the point and the size. You know already the size. This is the height and the width. And the point is actually, again, a struct from .NET that contains the X and Y coordinates of the element. Again, both the Android native element and the iWeb element, both of them have these two, the point and the size. This is why inside our component adapter, actually in our iComponent first interface, we are deriving from this iLayout component. We're doing the same for the mobile interfaces here. We're deriving from the iLayout component. This means that my Android component now needs to implement the iLayout component. And as you can see here, I added these two properties. It's the same thing for the web component. Right now, in my web component adapters and the Android component adapter, I have these two properties: point, which is the location, and the size. That's it. That's the only thing that I need to change into my two projects here. After that, if I add this namespace, the using to it, all of those methods will be available for me. The way this works is that we have a very simple assertion here that, as you can see, we are calculating the actual distance. I'm not going to overcomplicate the explanations now with all of these calculations, but they are very simple calculations regarding the coordinates about X and Y and how they are rendered on the browser. You can read that into on the WebDriver in the APM documentations. But in this utilities class here, it contains only a few of those calculation methods, while calculating the right distance, the left distance, the above distance. Again, as you can see, we're just the calculation is slightly different. And then when we calculate the distance like that or below, if this is not true, then we are going to provide this message: this particular element should be below of this element, but was something else as pixels. So this means that we will have a very nice explanation message what failed. So this is, and additionally we have this layout assertion static class layout assert that again it contains some complex calculations here, but it's basically for reaching all of the layouts that we provided as params. This means that this params keyword, it allows you to provide any number of parameters here. And as you can see, we are providing them as an array, but we are just separating them by commas when we use that. So this is the layout library. Next, let's focus on implementing the web quality execution. I already showed you the lambda test attribute, right? The one for the demo website. Right here, I have this lambda test attribute. This allows me to execute my test in the lambda test cloud. Again, mentioning the browser version, and even mentioning here the desktop, the resolution itself. The way this works is, again, I can show you that our tests already have been executed in the lambda test cloud. Here is the web execution. It's quite excellent because, as you can see, I can pick any configuration as I want, any operating system and any resolution. And on top of that, I will have all of the commands. I will have this very nice video of what happens and how it works. Yeah, and we can do the same for the mobile app execution. I'm going to achieve the same for the executing of our native apps. As you can see here, I executed that on Pixel 4, Android version 13 for 9 seconds. And as you can see, we can see all the APM commands here, and we can see a video of what our test is doing, which is excellent. We are opening it, we're clicking on the buttons and the checkboxes, that's it. And also we'll have we will execute similarly on a mobile web browser the same test for asserting our website, which will be quite awesome, right? So how this works in our web project now, inside the plugins, I have created additional attribute called lambda test attribute. As you can see, we have a lot of new configurations. Why is that? In order to configure that, you can open this lambda test capabilities generator. We have two options. We are going to use both of them for Selenium and for APM. Let's begin with the Selenium part. We are going to use the new Selenium 4 syntax, 𝑨𝒏𝒕𝒐𝒏, as you can see here. And then you have some advanced capabilities like changing the operating system. You can pick between many different browser versions if you need to support other ones. Again, you can change the resolution, which will be something that we are going to do. This added this particular line. And as you can see, the way this works is that we are not adding all of them to the Chrome options, but instead we need to create this dictionary of strings of objects, initialize this dictionary, and provide the username, the access key, and also an important one is this options name of this capability of this option, and providing the dictionary here. The same thing goes for when we work with APM. For APM, as you can see, you have different operating systems, iOS and Android. For now, we support only Android. This is why we can pick among different devices. I'm going to use Pixel version 13. Also, you need to upload your application. When you upload it to Lambda test, this URL will be given to you. This will be your unique URL to your application. I have already uploaded to my trial account this demo application, and we have the URL to it. And as you can see, it's very simple. We need to provide the Android, the platform name, the device name, the platform version, and whether this is a real mobile. And we are going to work only with real mobile phones. Now, I have created additional configuration that it's under this configuration folder. It's called grid configuration. We have the provider name. In our case, this will be equal to lambda test. We have this options name. This is LT. If you remember here, if we switch to 𝑨𝒏𝒕𝒐𝒏 protocol, we have this LT options. This will be the options name. We have the URL, which will be this specific both URLs are different for the two clouds, whether it's mobile or web. And then we have this special dictionary with string and object. Now, when we have this grid option, it's absolutely the same for the mobile. Again, we have one attribute for the grid. Again, if you don't want to lose lambda test, some people prefer to use their native Selenium grid, using it on Docker in Kubernetes, which is fine. But again, don't think that this is free. It's not free, because when you host it on your own machines or in your cloud, you're paying money for it, and then you spend a lot of time when you need to maintain that. In my experience, usually the many times when we decided to maintain it ourselves, usually this is much more expensive than to use some of these native clouds. This is why usually we use lambda test. But again, it will be, you need to calculate that and see whether this works for you. Again, if you're using native Selenium grid, you can use this grid URL. You can provide the browser and the browser version, and after that you can configure here the grid configuration. But the most important thing is that this grid attribute is containing this property here for the grid settings. And after that, again, this grid attribute is deriving from our vocal execution attribute. This means that it has access already to all of the previous settings. And after that, we have the lambda test attribute. And this lambda test attribute, as you can see, we provide the browser version, the desktop size. We have some default values. This means that you don't need to supply them later. And we are initializing, we are converting this browser version string. If it's 0, which is easier to provide it as an integer. If it's equal or less than 0, then we provide latest, or we're converting it to string. Then we're initializing the browser configuration with some default values. Execution, actually here we need to switch to lambda test. This was a bug. And then we are initializing the grid settings. We are initializing options to LT options. We are getting the username and the access key from the environmental variables. We are building the URL. We are converting the resolution to a string. As I told you, here we need it in this special syntax with the weight and the height and x. And then we have some default values for the arguments. Of course, later we can extend our framework to be able to add additional options here, or to be able to change that. I'm going to teach you how to do that next time when we have global settings, files, and configuration classes. So when we execute, when we configure that lambda test attribute, we can put it on top of our classes here in our tests, like that right now. And if we execute that, this will be executed in our lambda test grid. If I run that, you will see that this will be executed in my lambda test account. As you can see, it was refreshed automatically, and it will start executing on the particular version. All right. So as you can see, we are executing the same test on the lambda test web. But the way this works is that I extended my browser 𝐴𝐴𝐶𝐿 plugin. I basically now I have here a field that is referencing my grid configuration, and also below that, as you can see, we have two additional methods that are using a reflection to check whether we have these two attributes, lambda test attribute. And we are checking, do we have a class level? If we have it on class level, but if we have it on a method level on top of the test, this means that the test level attribute will override the class level attribute. And then we are going to return the grid configuration, getting the property. And after that, we are just providing, and as you can see before, here we were throwing not supported exception. Right now we have a new method called start grid. The way this works is that inside this driver factory, in our driver factory here, we have a new method called start grid. It accepts now the browser configuration and the grid configuration. We are initializing the options. Basically, this class will just return Chrome options, Firefox options, etc. And the important method here is this grid options, which will just return, it will initialize this string object, and it will add it using the options name. In our case, this will be the AOT options that I showed you before that were important to us, not from here, but from the capabilities generator right here. This one will add this dictionary to the capabilities, to the options. All right, and what else? We are initializing the grid execution, initializing now a remote web driver instead of Chrome driver or Firefox driver, and we maximize the window. That's it. That's the only thing that we need to do to start it into grid mode. I did something very similar for mobile apps. Again, you will notice that I have a very similar attribute here for Android. So for the mobile version, we have under the plugins namespace, we have app configuration. This app configuration now, it contains a property to the grid settings, and we have the lambda test attribute that again derives from the grid attribute. And here the only thing that it's different is that these settings arguments here are a little bit different for mobile, right? We're mentioning that this is a real device, that basically we're auto granting permissions, etc. And besides that, in our app lifecycle plugin, it works in a similar fashion. We added these two additional methods for our attributes, and into the driver factory, again, we have this grid mode where there are two specifics, by the way. If we execute into the cloud on mobile web device, then we just need to, instead of providing the app path, we just need to initialize the browser name. Otherwise, we need to provide the path to the application and add these capabilities for app package and app activity. In case we have this specific string, which, if you remember, this is part of the URL to the app itself that was uploaded to Lambda test, then we are initializing it like that. Or in case we are working with local grid, in Selenium grid, then we are working with our regular approach, building the path from the resources folder. After that, we just initialize here. We are adding the grid options, and then we are initializing normally the Android driver. That's it. Now, in order our web stuff to be executed on mobile web browser, as you can see here, I again used this attribute lambda test, mentioning the Android version, the device name, Pixel 6, and right now it's different because we are missing the app package and the app activity, but I have that we are using that this is a web test, right? By default, we are going to run it on a Chrome. And as you can see, right now we are working with our mobile library. However, everywhere, as you can see, we are using this iWeb service. If you remember from the previous module, we defined that, and we're combining both the mobile and the web. And the way this works is that, again, I copied the same mobile test here, right here. If I run it into the cloud, You will see that under web application right now, this will be executed on Pixel 6 version 13 on this particular resolution, which is awesome. We are using the exact same, as you can see here is our web browser is opening on a real device, which is Pixel 6 on this version. This is quite awesome because otherwise if you use a regular APM server, this is much harder to configure. Imagine that for every device we have a different Chrome binary, different version of the browser. This means that depending on your emulator, you need to download the specific Chrome driver binary and provide it here, or if you execute that through 𝐾𝐞, if you start the server, then you need to provide here the exact proper driver version. For example, if your Pixel 6 is requiring Chrome driver version 120, then you need to provide the proper driver here. If you use S20 device, then here, I don't know, maybe you need to provide Chrome 125, because otherwise when you use the emulators you cannot control or update the browsers. And you need to do this by hand. It's a lot of maintainability. However, when you execute that in the Lambda Test Cloud, this is awesome. They are doing this out of the box for you, which is quite awesome. I really like that. And the way this works, I extended a little bit our web interface now to support. If we open here, I added, as you can see here, the availability to create pages. And right now we are using the same page objects that we were using for our web tests, but we're working with them in here with mobile web tests. This is quite awesome, right? Again, we're using totally the same page objects with you know, app elements, with all of that, right? I did a few changes to our driver adapter here for the mobile. I just added this line here where we are initializing the driver factory wrap driver to the Android driver. This was the only change that I did, and this works out of the box for you. We are combining both modules, which is quite awesome. And this will work also for hybrid applications, which, as you know, they are not like native Android applications, but they're loading like a native application. But beneath that, when you work with all of the elements on the screen, they're actually rendered in a web view, many often using, for example, React Native or Xamarin or similar technologies. I have tested that. I was like half a year ago, I was involved in such a project where we use React Native and Xamarin, both of them, and this is working like a charm out of the box directly in the Lambda Test Cloud, which is quite awesome. Yeah, I think we covered everything that I wanted to show you. We looked and discussed what is the responsive design testing and why it's really important. We implemented this type of emulation using extending our local execution attributes and the browser plugin and the app plugin. Again, if you have the chance, always prefer to use real devices. Sometimes there are some glitches with the emulators. There are some troubles, especially if you're you know, working with Android emulators. Sometimes they are crashing. You need to maintain them. The same is valid for web emulation. It's not always absolutely accurate as real devices. And yeah, you saw how we can execute the tests in the Lambda Test Cloud, both for web, both for native and hybrid applications, and how we can reuse our web module inside and combining it with our mobile module to execute our web tests together with the layout library into real mobile devices. Next, we are going to talk about configuration management, which will be quite important instead of hard coding a lot of, these magic numbers everywhere, especially about the timeout settings. But also, this is really, really important when we want to execute our tests on different test environments like staging, QA, development, etc. Or when you have different configurations for the various mobile devices. So wait for the next module. Thank you for watching. If you have any questions, put them in the comment section below. Check the Awesome Blended Test blog and the community website, and don't forget to get your free certification about NUnit, Selenium, RPM, JUnit, and many more technologies. Thank you for watching, and see you in the next module.